In order to add resources to our plan, we need to know what resources are required for each activity. So again, we go back to our activity list and we list the resources required for each activity. Now, to make this example simple, let's assume that we only have one resource, and that is people. So we would list the number of people required for each activity and simply add those on to the activity list. Now, also, in order to keep this simple, let's add those resources to the bar on the early start bar chart. Now we have the resources required for each one of those activities shown in each of the 1 hour time periods. We also have the early performance of each bar, and we have the floats for each activity as well. Now we're in a position where we can create a graph showing us how many people we require for each time slot. That is called a histogram of resource requirements on early start. And in order to do that, we go to each one of those time slots in turn and add up the number of people required for that time slot. So, for example, for the first time slot, we see we have only one activity during that time slot between 0 and 1, and that is the disconnecting of the machine, and that requires 3 people. So we enter that onto our graph or histogram. Then we move on to the next time slot between 1 and 2. And we see we require 2 people to service the input side, one person to service the output, and 1 person to remove the old wiring. So 2 plus 1 is 4, and we enter that on our histogram. Then we move to the next time slot, and again we need 2 plus 1 is 4. And we move to the next time slot, and again we need 4. Moving to the next time slot, we see there is only one activity going on there, and that is the servicing of the input side, which only requires 2 people. So our histogram shows 2 people required there. And in fact, moving on to the end of the project, each of those time slots only requires 2 people. So there we have a histogram of the resource requirements or the number of people required in order to accomplish this project in 9 hours. Now we have the ability to level resources as well. So, for example, if we only have 3 people, we can enter our resource availability of only 3 people onto our histogram. And immediately it becomes apparent that we have a problem. The area in red, the peak on the histogram, is a resource requirement that is above the availability. What that means is we need more people than we have between hour 1 and hour 4. We need 4 there, and we only have 3. So how do we cope with this situation? And the solution to the problem is, in fact, resource leveling. What we want to do is move activities so that we can get rid of the red peak on the histogram by moving it into the white space below the resource availability. So if we could accomplish that, then we would have leveled our resource requirements. Now, we don't want to extend the project duration above 9, but fortunately, now we have the floats which have come from the previous steps. We are able to move our activities within the dotted arrows or red arrows, within the float, in order to reduce the resource requirements below our availability without extending the duration of the project below 9. Okay, so how do we actually do this? There are three options in this situation that are available to us. And let's have a look at option 1. The dotted arrows show free float, so we're able to move any activity within its free float without affecting any others. The red line, the red arrow, is interference float, and what that means is if we move that activity out at all, it is going to interfere with the following activity, so we would have to move that as well. So let's have a look at option 1 of simply moving an activity within the free float. So we take service the output side, we move it out within the free float, it doesn't affect anything else, and we have leveled our resource requirements. Now let's look at a second option. Option number 2. Again, we have moved activities within the free float. This time we've moved 2 of them, service the output side and install new wiring. But both of them have moved within their green arrow or free float, so they do not affect anything else. But there is a third option. Let's look at the third option as well. In this case, we have moved the remove old wiring task. That task has interference float, so it has pushed out the install new wiring. But fortunately, install new wiring has free float, so that has moved within its free float. Now, each of these three options have given us the ability to manipulate our resources in time within the floats and level our resources so that we are able to accomplish the 9-hour project in 9 hours with the limitation of only 3 resources. None of this ability would we have if we did not know the floats. We would not know the floats if we did not have the network. So it's becoming apparent that this is a process of starting with the activities, building the sequence and network, creating the bar chart, adding the resources, leveling the resources. It is a process. Again, let's take a step back and examine what we've learned so far. By having the floats on the bar chart, we were able to level the resource requirements without extending the duration of the project. We also found that we had 3 options available to us for leveling the resource requirements. Neither of these would have been possible if we did not know the floats. We would not know the floats if we did not have the network. Once we have produced our final schedule, we can put it onto a real-time calendar. So let us imagine we choose option number 3 from the previous step. Going back to the previous step, we make this option number 3 our schedule, our final schedule. Now we notice that in this one, our critical path shows us we will complete the project in 9 hours. And we have moved 2 of the activities in time in order to bring our resource requirements below our resource availability. We notice too that at the bottom of the resource histogram, the timing information is in hours. Now, this would be a lot more valuable to us if it was in a date-time format. So we define our calendar to show working time and non-working time. Our working day, let's assume, includes 8 hours from 8 a.m. to 5 p.m. with a 1-hour break for lunch at noon. So we enter our final schedule onto our working day calendar, and we notice that our project is going to take more than 1 day. We end up at the end of the first working day with 1 hour of work left on align the input and output. Now, this may not be what we want at all. It would be far better to do it in 1 day. So let us assume we want to complete this in 1 day. So our first option might be to get our final crew who are aligning the input and output to work an extra hour or work overtime on the first day. If that's the case, then choice number 1 for a single day project would look like this. We have the align input and output crew of 2 people just working overtime. However, we think about this as well, because service the input side, that is also a crew of 2 people. It might be better to eliminate that break in that activity as well, because continuous work for the servicing might be an improvement as well. So perhaps if we were able to eliminate the break in service the input side, that would make an improvement. So we look at our single day schedule, choice number 2, by eliminating the lunch break for 1 crew on day 1. And we see that looks far better because nobody has to work overtime and none of the major tasks are being split. They're all continuous work. So we would probably decide that is the schedule and final plan that we're looking for.